Welcome, and thanks for listening to Intrinsic Investigations. My name is Mr. Olivo, and I created this podcast because I've been fortunate enough over the last decade to see unique and thought-provoking projects happen in my classroom, and we wanted a place to showcase them. The true heart of this podcast lies not in the content discovered, but in exploring the personal stories of these young researchers as they journey through uncharted and unfamiliar intellectual terrain. By sharing their stories, we hope to normalize the challenges and frustrations that come with independent research, and also share those moments where students transcend the normal grind of the school day to discover concepts that range from the global to deeply personal. We will begin with a brief introduction to the student of focus, why they picked their topic, and discuss their growth over the course of the last year. It should be mentioned that the opinions expressed in this podcast in no way reflect the opinions of our school district, Bergen County Technical Schools and Special Services, or our school itself, Bergen County Technical High School, Teterboro, or the College Board. The work detailed in this podcast was most likely completed in AP Capstone, but this podcast is in no way affiliated with the College Board. My guest for this episode is Luke, who will be looking at the discrepancies between ground level and satellite measurements of light pollution. All right, for this episode, we're going to the land of physics a bit and computer science with Luke. Luke, you want to introduce yourself to the people? Tell them a little something about yourself. Who are you? What do you like to do?
Hello, everyone. My name is Luke Rudolph. I'm a junior in the business major or strategic asset management major here at BT, and I am an avid Magic the Gathering player. In fact, I run the club here at the school.
All right, so school, Magic the Gathering, anything else in the life of Luke?
I mean, I'm also a bowler. That's fun.
This is what I hear. You're a very talented bowler.
Yes.
All right. Now, none of those things that we mentioned, bowling, Magic the Gathering, or strategic asset management, have anything to do with your project. So
Yep.
What was your project about?
My project was about measuring the discrepancies between satellite-based and ground-based measurements of light pollution.
Why should we care about light pollution?
Well, it's been shown to affect a variety of different fields, one of which being human health. So, yeah, if you're overexposed to it, it can lead to health detriments.
Like what?
If I remember correctly, it can interrupt the circadian rhythm, which affects melatonin production. And then in addition to it, it's also been shown to lead to increased risks of developing certain types of cancer, specifically breast cancer.
And this artificial or light pollution that we're talking about, as a species, we're inundated with artificial light.
Yeah.
I mean, right now, I'm recording on a laptop that is sending artificial light my way.
Yep.
Is there a difference between the two, or is any artificial light in this same ballpark of disrupting circadian rhythms and possible cancer relationships?
I believe it's any artificial light. So the main focus with light pollution is just trying to reduce like excess light. So like light that shouldn't be where it is.
And yeah, I get that. So would being on one's phone until 3 a.m., let's say, be as harmful as having a lamp outside of your home that kind of reaches into your window? Are you
I
sure?
don't know.
Okay.
Unfortunately.
But we do live in a world with a lot of light. We do. All right, so the issue was you were looking for discrepancies between satellite data about that light and ground level data.
Yep.
How'd you get the satellite data?
I just got it from the New World Atlas of Artificial Night Sky Brightness and the VIRS, which I keep forgetting I got it later on in my research process, so I wasn't able to fully remember its name. I believe it's like the visual infrared imaging radio. I forgot what it was.
That's okay. That's all right. But regardless, you were able to get reliable readouts of what satellites were reporting as light pollution levels in those areas.
Yeah.
So then how did you go about getting the ground level?
I created my own little rig consisting of an Adafruit light sensor, Raspberry Pi, a battery to keep it all charged, and a little container to keep it all protected from the weather.
Cool. And where did you house this, did you give it a name? Like what is it?
I did not.
Right.
We could just call it like a rig.
How did you, okay, so your light measuring rig, your sensor rig. So where did you house this sensor rig?
I housed it across multiple locations scattered throughout Bergen County. Essentially, these locations were selected via convenience sampling. So I got the locations by asking like different people at the school if I could set up at their house. BT is a magnet school, so we got a lot of different people from different towns across Bergen County. So because of that, I was able to get a variety of different towns across Bergen County to set up in.
And just even without, we'll get into your data later, but even without getting into your data, from the different towns you explored, were there radically different levels of light pollution that were apparent to you? Like, what's one town you were in?
I would say North Arlington.
Okay, so you're in North Arlington. What's another town you went to?
Leonia.
Okay, so between North Arlington and Leonia, just in, I'm assuming, driving there and getting your sensor rig set up, was there anything that stuck out to you about the level of light pollution in those areas as being unique to those areas, or?
There were definitely differences, but a lot of it came down to like the layout of each individual location, because the houses I visited were all like fairly distinct locations, so they all had different sources of light pollution, or just different sources of artificial light.
And these were all single-family homes, not in commercial areas, or were there any apartments or any like mixed-use condos?
I'm not exactly sure, but none of them were in like close to commercial areas. I don't know if there were any like special type of housing though.
Okay, so when you went there, what did you see as the common sources of light pollution in those spaces?
Street lamps, like decorative lighting, like cars were like a minor issue, like because I decided to set mine on like the front lawn of all these houses to try and keep it consistent. So that means that cars would pass by every now and then, influencing my data.
But nothing else would be the case. Like there's no other sources of ambient or ground level light that were causing issues there.
Well, it's just kind of like street lamps and like housing.
Okay, so street lamps and just the decorative lighting of houses were the main things there. What then? So you got your sensor rig. You're measuring that data. What did that data reveal about the satellite data compared to the ground level measurements you were taking?
Essentially, there were environmental differences led to variations between my data sets. Some of these data sets seemed to show that there were two groups, one of which was relatively higher, or like relatively different from the points of comparison, while the other one was a little bit closer, although still noticeably different. So essentially, there's no one quick version of comparison, although there may be like there's no one size fits all, but there might be like some different values that you could use depending on the conditions in which of the location surveyed. Does that make sense?
Yeah, well, I'm going to ask a couple of questions. So the environmental conditions, I know you mentioned cars. Do you feel like you got a good capture of that ground level radiation ground level light exposure even with the anomalies like cars, like just sort of like what the baseline is based on the decorative lighting or the lamp, the light posts?
I think so, because I don't know if I mentioned this, but essentially when I put my rig at each location, I left it running the entire night. Mm-hmm. So it would basically be taking like little snapshots every few seconds and then reporting that into a file, which I then like put into a spreadsheet. So because of that, I think I was able to get like a decent feel for the overall amount of artificial light in the areas.
All right. So now before we were discussing the problem, you brought up this idea of light pollution, light exposure disrupting circadian rhythms, which are obviously important to sleep and neurological function, and also possible cancer links, specifically breast cancer that you mentioned. So the satellite data that's out there, that's more readily accessible than your sensor data that you gathered in these small towns.
Yes.
Well, or they could be large towns. I'm not trying to, in these towns. Sorry that qualifier. Should people be concerned? Should they be looking at that satellite data? I know you came across it because it was part of your research, but if someone wanted to check and be like, hey, what is the level of light pollution? Is that data reliable based on the work that you did? Reliable enough that they could infer like, hey, maybe I should put my blinds down when I'm trying to go to sleep or when I'm ready to turn down for the night. What do you think? Or I should say, what did your data reveal?
I'm not sure because my data shows that there is like a discrepancy between the forms of measurement. So like if you use like the satellite, it may not exactly equate to exposure. However, there are studies that have shown like a correlation between the values, so you may still want to be aware of it if you live in an area where you're highly exposed to artificial light at night.
In your satellite data, did you come across any particular areas where you're like, whoa, that's a significantly higher amount of light pollution than you initially expected?
I don't remember which location it was. I think it was either actually the place I mentioned before, Leonia, or North Arlington, where like the values were like very high compared to like the New World Atlas data, and I was quite surprised by that because although like that location did have like noticeable amounts of artificial light, I didn't think it would like equate to that much of a difference.
So of the towns that you went to, which had the largest amount of light pollution registered by your sensor rig?
I believe it was North Arlington, Leonia, and Fairlawn.
Oh, like are they all tied, or are they?
No, but they were all like in the higher threshold that I was mentioning earlier.
Okay, so those three all had. It wasn't significantly different, so they're all in that ballpark. Oh,
yeah.
Okay. What were some challenges? This is a pretty unique project in the sense that I think it's the only one that involves physical computing or the coding of some kind of, device for turning some obviously light data into something that's measurable and analyzable. So, what were some unique challenges that you faced with making this project happen?
So, as I mentioned before, I did use convenience sampling, which, while it does have convenience in the name, it still is not 100% convenient because, despite the y-axis, to different students from different towns, I'm not asking the students for permission. I'm asking their parents, who may not trust me as much. So because of that, I did have some difficulties with locations.
Were there people who just rejected your proposal? They're like, yeah, I don't want this thing on my lawn.
I'm not sure, because most of the people I asked were those who I already knew fairly well. So they were fairly willing to help me with my project.
Oh, but what was the example you were giving before of people not being willing to help because they didn't know you?
That was an issue with the parents. The person I asked was willing to help, but then I needed consent from their parents, and their parents said no.
What were the concerns about your experiment? Was there ever an explanation, or was it just, nah, I don't want to be part of this study?
I don't think I ever got like a good explanation.
You know, that's the right of a research participant. They don't have to give you a reason why. They can just say no. And that's totally fine. That's why we have ethics in research, everybody. So in doing this project, what would you say, I don't know, what moment are you most proud of? Because there was a variety of things going on between building your sensor rig, presenting the data, writing, trying to communicate with others to give them access to their lawns for light measurement, which didn't always work out. But what would you say was significant for you in terms of growth?
I feel like, although I am kind of still working on this, over the course of my project, I've had like a lot of trouble describing it because like it's on light pollution, but it's on the measurement of light pollution. So over the course of my project, I've had to try to figure out how to adequately describe it to people so that way they would understand, but I also feel like I'm conveying everything I need to.
So it's getting people to, I guess it's feeling understood.
Yeah.
Do you feel that people are understanding what you've done over the last year?
Mm-hmm.
All right. Does it make you look at light pollution any differently? Maybe this will be our last question. So does this make you look at light pollution any differently, and if so, how?
I don't think it's light pollution, more so light sources. Like, if I'm out and about, like, I don't remember where this was, but the other day I was on a car ride. I don't remember where to, but I was just looking out the window, and then, like, a fair distance away, there was, like, a field, and, like, with one of the, I think they're called floodlights, and I could see the light of the floodlight, and I was just like, I don't need to see that here. That's light pollution. So, like, I become a lot more conscious of different sources of light, and, like, yeah.
And the floodlight was just on for...
I think there was a sport.
Oh, okay. All right. Well, there was a sport being played. It wasn't for no...
Yeah, but I was, like... I don't know if I was a mile away, but I was still, like, a fair distance away.
Oh. Like, the intensity of the light was just very...
Yeah.
All right. Okay,
like,
cool.
I didn't need to be seeing it from that distance away. Like, I wasn't on the field. I was, like, well off the field.
Gotcha. Well, I guess discussing how we engineer things so that there's less of that is a whole nother podcast. Maybe that's next year. All right. Well, thank you for your time, Luke. Anything you want to say to the people before we go?
I don't think so. Thank you for having me.
Yeah, no problem. And that's that.